Hello class, we're about to start section 9.4 using the square root property to solve quadratic equations. We already know one way to solve a quadratic equation. We know that by factoring. Use this method to solve x squared minus 16 equals 0. We know this is the difference of two squares, so we will have x plus 4 and also x minus 4. They both are equal to 0. So we'll take x plus 4 equals 0 and x minus 4 equals 0. We'll subtract 4 on both sides. X is negative 4. We will add 4 on both sides. And x is 4. So these will be our solution here. Now, it says solving a quadratic equation with the square root method. Isolate the perfect square on one side of the equation. Be sure the other side of the equation has only a number, no variables. Take the square root of both sides. Include both the positive and negative square roots. Solve for the variable and simplify the answer. Okay, so now we're going to take the same problem, but we're going to use the square root method. So the first thing we need to do is add 16 on both sides. So we will add x squared is equal to 16. So we would take the square root of both sides. So the square root of x squared will give us x, and that's equal to the square root of 16 will be positive and negative 4. So it'll be positive 4 and also negative 4. Now you could write it like this, or you could write it like this. Either way is acceptable. Does everyone follow that? Okay, now we move on to the next page. It says the square root property. Let k be a non-negative constant. Then x squared equals k has two solutions. It'll be positive and negative square root of k. Now it says solve x squared equals 9. So we will have x squared equals 9. We'll take the square root of both sides. And x is equal to positive and also negative 3. It says warning, the equation x squared equals 9 has two solutions. Negative 3 and also 3. Recall that the square root of 9 is the one number 3. Now, what this is saying is if you just are presented with the square root of 9 and it's not part of an equation, then your answer would just be 3. But since this is part of an equation where we have to take the square root of both sides of the equation, that's how we get the negative 3 and the positive 3. Does everyone follow that? Okay, so now we go down here. Solve the following using the square root method. Now we have x squared is equal to 7. We'll take the square root of both sides, and we have x is equal to positive and negative square root of 7. And we can't do anything else with the square root of 7 aside from just put it in the calculator. Now we come here to b. We will add 50 on both sides. And we will have r squared is equal to 50. Now we would take the square root of both sides. And the square root of r squared we know is r. Now we know we will have a positive and negative answer here. But doesn't 50 have a perfect square in it? 25. So we will break this down to square root 25, square root 2. So it'll be r is equal to plus or minus the square root of 25 is 5 times the square root of 2. And that is the final answer for B. Now we come down here to example 3. It says solve the following using the square root method. Now this requires us to do a little bit more work, but we can handle it. We will first subtract 5 on both sides. So we add 3x squared is equal to 75. Then we will divide each side by 3. And we will add x squared is equal to 25. Now we would take the square root of both sides. The square root of x squared will give us x equals plus or minus the square root of 25 is 5. So it would be x is positive or negative 5. Any questions on that problem? Okay, now looking here at D, we have this parenthesis 2x minus 1 and parenthesis squared is equal to 49. Now we could take the square root of both sides, and then we would end up with 2x minus 1 is equal to a positive or negative 7. Now we would add 1 on both sides. So we had 2x is equal to 1 plus or minus 7. Then we would divide each side by 2. And x is equal to 1 plus or minus 7 over 2. Now one thing I need to stress here is that when we have a solution like this, we typically try and write it out as two separate numbers. So we can have x is equal to 1 plus 7 over 2, and then also 1 minus 7 over 2. Now we know 1 plus 7 will give us 8. So that will give us 8 over 2. And 1 minus 7 will give us negative 6 over 2. So our final answer would be x is 4 and also negative 3. That would be our final answer for that problem. It's a little lengthy, but we can handle it. Okay, now we come to example 4. It says solve the following using the square root method. We have 8n squared is equal to 3. First thing we would do is divide each side by 8. And then we will have n squared is equal to 3/8. Now we have to take the square root of both sides. So now we will have n is equal to positive or negative square root of 3/8. Now we know we could change this. This end up being n is equal to positive or negative square root of 3 over the square root of 8. Now we know the square root of 8 has a perfect square in it. So it would be x is equal to plus or minus the square root of 3. This will give us the square root of 4 times the square root of 2. Now the square root of 4 we know is 2, so it'll still be n is equal to plus or minus square root of 3 over 2 square root 2. Now here's the problem. We cannot leave it with the square root of 2 in the denominator. So we have to multiply the numerator and denominator by the square root of 2. So this would give us plus or minus the square root of 6 in our numerator. And our denominator, now watch this. The square root of 2 times the square root of 2 we know is 2, right? And isn't 2 times 2 4? So it'll be the square root of 6 over 4. So it'll be positive and negative square root of 6 over 4 would be your final answer. Are there any questions from A? Okay, now we look here at B. The first thing we would do here with B is add 8 on both sides. So we add 2 times x plus 3 in parentheses squared is equal to 108. We divide each side by 2. And x plus 3 in parentheses squared is equal to 54. Now we will take the square root of both sides, and then this will give us x plus 3 is equal to plus or minus. Now the square root of 54 has a perfect square in it. We know the highest perfect square in 54 is 9. So it'll be the square root of 9 times the square root of 6. So we have x plus 3 is equal to plus or minus 3 square root 6. Now we will subtract 3 on both sides. So we have x is equal to negative 3 plus or minus 3 square root 6. And that is our final answer. Okay, now we go here to C. Now, if you notice, we had 9 times this parenthesis, and it's equal to 8. So we would divide each side by 9. And then we would have x minus 2/3 in parentheses squared is equal to 8/9. Now we would take the square root of both sides, and we would have x minus 2/3 is equal to, this would be plus or minus. Now we could break this up as the square root of 8 over the square root of 9. Now we know here the square root of 8 has a perfect square in it, which is 4. So we add the square root of 4, and then it will be multiplied by the square root of 2. And the square root of 9 we know is just 3. So we have x minus 2/3 is equal to plus or minus, it's supposed to be 2 times the square root of 2 all over 3. Now we have to add 2/3 to both sides. So we will add x is equal to 2/3 plus or minus 2 be 2 square root 2 over 3. Now we can leave it like this, but typically you will find the final answer written in this form. It'll be 2 plus or minus 2 square root 2 all over 3. So we will bring it all together here. Now this was a long problem, but again, like I said, we can handle it. Now we go here. Now if you notice here, we have no numbers here. We have all variables. But we would do this the same. We would take the square root of both sides. So we would have bx minus d is equal to plus or minus the square root of k. Now we're trying to get x by itself. So we will add d to both sides. So we have bx is equal to d plus or minus the square root of k. Now we would divide each side by b. And our final answer would be x is equal to, this equal sign, correct? So x is equal to d plus or minus the square root of k all over b. And that will be our final answer. Okay, so now we're going to move on to this next page here. Now this next page has story problems. So if we look here, we have example 5. The poverty threshold in dollars for an individual under 65 years old in the U.S. at T years since 1900 can be modeled by this equation here. It says find P of 95. What does it mean in this situation? Now, first of all, we could talk about, we could put this in our calculator. So 95 will replace T. So we could take 4.95, then we could do our open parenthesis. It'll be 95 minus 57. Close our parenthesis and take that parenthesis to the second power plus 1,406. Now, this would mean that P of 95 is equal to $8,553.80. And it asks us, what does it mean in this situation? In 1995, the poverty threshold for individuals under 65 years old is $8,553.80. That is what is meant by the P of 95. Okay, now it says find T when P of T is equal to 3,000 by hand using the square root method. What does it mean in this situation? So we'll replace the P of T with 3,000 and we'll set it